Hi, welcome to another video. So today, as before, Mikroelektronica's EasyPick Fusion version 7 PIC32 MX795 microcontroller. Now I've been messing about with Mikroelektronica's sample MP3 player and this chip, the MP3 decoder. Now I was going to demonstrate how the length of a character array can give you a bad day, and that is exactly what has happened to me. The program was running for hours and hours yesterday, turned it off, went to bed, got up this morning, that's all it gets to. Right, so if I reset this, so that's the audio MP3 player. That Mikroelektronika give you an example. So what it's doing, I've got 5 songs on this SD card, FAT16. I'll explain that in another video, the FAT16 file allocation table system. I'm reading the names, and Mikroelektronika's MP3 player will just play one piece of music named music. The music MP3 file name can only be 12 characters long, including the .mp3. Although it will learn the FAT16 first, then go on to the FAT32. So I've got 5 songs on there, and you see it reads the boot location, finds the FAT table, goes to the root directory, and that's what I've got. Is come up Santa Claus. Now Santa Claus is actually a character array. I was going to do a video on character arrays and where you need pointers. Hopefully there's going to be a 5-minute video on where to use pointers and how to use them, because it's one of the least understood topics. But so that's just a character array. This is the string length, not of this character array, another one, but that should be now giving me file names, and it's stopped. So I thought, well, now it's stopped. I found my problem, but I didn't know how to use Mikroelektronika's debug tool. So this video is going to do that, show you how to use the tool. Now because these PIC32 MX795 microcontrollers, they've actually got a large memory. So the memory location numbers start at like 2 million. So we're dealing with 32-bit numbers. And that will make sense when I show you the debug tool, and where I pull these long numbers, you think, where do they come from? They come from the memory address inside the chip. Hopefully that makes sense to you. What I'll do, I'll set up the screen capture and show you some code. Right, so first of all, let me show you Mikroelektronika's help file, memory organization PIC32 MX. So we are dealing with this area here, and you see this is actually 8 digits long, so A0 7 zeros. Internal RAM. Now they refer to it as a virtual memory map, but have a read of the description, you'll understand. So that's why we're dealing with big numbers. You've got to understand where those big numbers come from. Now my initial video was going to show you some character arrays. So this is a character array, and seeing how we are on the 9th of December 2017, Christmas is fast approaching. I've got a character array. You can see 10 characters, but because the character starts at 0, that's actually 11 characters. I was going to do a video on why the string needs to be 12 characters long. And then just to show you a simple example of pointers, I've got the day of the week pointer. It looks at the days of the week and pointers pointing towards Monday, Tuesday, Wednesday, Thursday, etc. So that's where it all began. Plus this program plays MP3 files. So I get the boot directory information, show the boot information, that's a sector of the root directory, read the root directory, data buffer, that's 512 bytes long, and then show the name and a small delay. That's the MP3 player, the modification to Mikroelektronika's example. Have a look at the example. You can play one song, and that's it. Once you play the one song, it's done and finished. With this information, I'll get the name of the song, and you'll be able to put an infinite amount of songs on your SD card. This is primarily FAT16. Once we understand the FAT16, we can move on to the FAT32. Those videos will be coming along soon. Right, so part 2 of this video. go back to the help file, back to contents, and look for the size of an int. INT, int. So obviously an int is short for an integer, which is a whole number, not like a floating point, so it hasn't got decimal places. It's a whole number, and it says here from 0 to 65535. That's the size of an int. And you see it takes up the size in bytes up to 2 bytes. Assigned long takes 4. You see signed long, 8 and 8. Unsigned short, just 1 byte in memory, and S bit and a bit, it's just 1 bit. So this is the start of my confusion, looking at the size of the bits and getting them confused with arrays. So that's under int, integral types. So if you're not sure the size of the number you're dealing with, search up int, go down the list, floating point down here, 4 bytes, double and long double. Now incidentally, whilst I'm here, this signed long, I use it in this program. See if I can find the section. Right, so I remmed it out, so removed it with these two, backslash. So this char, if I undelete it, so you might have seen this in the CAN software if you've looked at it, or seen it in other programs. So I've got a character or char D, just the regular letter D, then absolute. Now, you think what on earth does absolute stands for? Absolute, and then this long number, which you've now seen in the address of the PIC32, that is writing the character D, writing it to the memory, the physical memory, at the start address there. And I'll show you that in one of my other tutorials. So if you look at this number, the first 2 bits are 8 bits, 16 plus another 8, and there's not quite another 8 with the A, but that's nearly 32 bits long. When you start using those numbers, it's a special function register. They're unsigned longs, and that large number you saw in a help file, I looked it up. So this one over here, which I was experiencing these long numbers on the UART terminal and my TFT, I thought, what is that? So I just copied this, pasted it into Google. Wikipedia came up. This is 92 quadrillion, and it just so happened that number coincided with an error PayPal made back in 2013, I think it was. They accidentally paid someone 92 quadrillion pound, but it wasn't too long before they found it, obviously deleted it from his account or had to get it back somehow. Partly make up for the error, PayPal offered him some money to a charity of his choice. So 1 minute you got just a regular bank account, next minute you got 92 quadrillion pound. So that 92 quadrillion pound is actually, I think they paid him short. I think it was just £1 short of a 32-bit quantity, which is why it went up to 92 quadrillion. And you see there, 92 quadrillion pound, 8 bits is a maximum. Just for the record, I think I made a mistake. If I accidentally refer to these as bits, I mean they're bytes. It clearly says it up there, but so you've got to go to project settings. Release mode, we want to change this to ICD debug. Then go run start debugger. Right, so it says release build or build type release. ICD build required for debugging. Now you get this error if the file has changed or been recompiled since the last debug. So click OK. Then whilst you're in that ICD debug under project settings, if you can't see project settings, the view project settings there. So now compile it again once we're in the debug mode, build and program. So now I'm reprogramming this in IZDB debug mode. That's it, programming. And you'll see it run through half the program. Actually, no, it won't. We're in debug mode now, so now it's not going to run through the program. So now start debugger. Right, it's all working as planned. So I'll switch to the camera view, and you can see we've got a red light on with the debugger started in the screen over there. So that started at the main. So now I'm going to skip through or jump through these programs, and it will run through every function, and this will change as I'm stepping through. This will change and show the boot sector, then all the information that comes up during the boot as I step through, but you won't be able to see that because I'll be on the screen capture. Right, I've had to rethink this debugger because I'm getting inconsistent results with this drop down list. So if I run the debugger again, final time, and the result will give us a pointer to the rough direction where the program is crashing. As I said, this program ran for a day. I altered something, programmed it, made a few adjustments, carried on running. Next morning, after turning off and back on again, boom, nothing. It halts, as you saw on the camera. Right, so don't need to build it anymore. I'm in the ICD debug mode, which means it's connected to the PIC. So run, start debugger. So I've been missing a point all along. So if we have a look, rather than look for a specific function, there's an easier way. It points us straight to it. Right, so as I said before, rather than hit the run to the end, it will take hours. That's if this doesn't crash. Just use the F8 step over. Now obviously if this keeps on jumping through every loop with no stopping here, no pausing, then you haven't got a problem. And obviously the program starts at the main, so it's running all these functions in the background. What you can't see off the camera, when I click this MP3 play, it runs through the play routine. It's now looking for a memory card. There's no song assigned, so that's just skipped. Right, this is my stuff, so it's getting my boot information on the TFT. Well, that's all working. It's it's running to the next step. Right, this is where the thing's booting up and reading the memory card. Hopefully you heard that little buzzer. So you can see up to this while one we haven't got any errors, it's not stopping. So this part here, if I haven't said before, I was going to do a video on string arrays and pointers, but that's going to follow shortly. This debugging I felt was more important because my program crashed and I didn't know why, and the debugger is a tool to help you. So let's step over that. When it steps over, it does run it. So I'm not totally au fait with the terminology, stepping over. Right, so this is where the program got to before, and it sort of halts here, so we know, right, we've got a problem here at line 1022. But real time, but it stopped. These buttons up here have blanked out, so let's stop that. pause. Right, so we've got a general exception in the exception program counter. Now if we click on this error, cause, actually I've got, I'll stop the debugger because it's paused, isn't it? Stop. Right, so I've stopped the debugger. So now that highlights this, the EPC. Get it to flash again. Right, it's stopping here at this specific address. So it's load byte unsigned. So that I've been missing all this. I've been knowing my fault. I was trying to look for specific functions or commands to show you, but this is what we're stopping at. Look, L string length. So you can see all around this, all this area is a string length. So then after the string length, we're back to the SD card. So where is it? Need to find it again. So string length, and that program halted. Go back to that program halted here, and so something to do with this string length caused an exception. So yeah, little note, go to conversion library. So from here, back to the help. Search conversion library. Right, byte to string, short to string. So right, byte to string, we want 4 characters. Short to string, we want 5 characters. Word to string, we want 6 characters. Int to string, which is what we're on, 7 characters. So how are they getting to 7? Because from those quotation marks, 1, 2, 3, 4, 5, 6, but they're not showing the blank null character at the end. So there's a blank here, but then look, 1 blank here. So that's the important bit. They're not showing the null character. So an int, which is only 2 bytes, I'm trying to point to the screen, but I haven't got the camera on. An integer, is 2 bytes in memory, but if you want to display it on the screen, you need 5 bits for the integer, plus the signed bit, which is blanked out, plus the null character, so 7, and I had 6. What I actually did, I'll take this out and put, I think, text. And if you're not familiar, press the Control and space. It'll give you variables beginning with whatever you've just typed, so text1. And you can see up here I've got text3 string, if it's actually in view on this screen capture. So text1 is a pointer. So if I program this, we'll see if it runs. Well, I forgot it's not going to run because I'm in ICD debug mode. So start debugger. Right, so that's gone back to the main. I've just programmed that, so let's go step. Alright, that's starting my program again. Right, that's finished. So if you've got a development board and you're using Mikroelektronika software, yeah, fire up the debugger. You don't have to be in this mode, ICD debug, where it connects directly to your board, you can do it in release mode and then bring up the stopwatch and see how long a specific function takes to run. You get a little stopwatch over here. If it's not visible, click on the view, then down to the debugger window, and then the stopwatch will highlight. Right, so we're down to a day of the week, no errors yet. Step over. If I run to the end, this freezes, and I've had to restart the compiler 3 or 4 times. And as a help file, say no pull-up resistors on the connection lines. There's various specifics you need in order to get the debugger to run and not crash. Have a look at the help files. Right, so I've just changed that C to text 1, and look, whilst we're in debug mode, it gives us the addresses and values. So look, that Y, which is declared at the top, is telling me it's 25. Look at that, it's just stepped over it. It's gone past that result. Right, so this is just where it's crashing before. So step over, step over, step over, step over. No, looks like there's a problem there. TFT write text A. No, it's stopped. So that screen was right before TFT, so stop, pause. General exception again, stop the debugger. TFT write text. So I've got a problem in that section. Got a problem here. Well, what the actual problem is was this text 1. So I can, if I remove this, the problem will still be there. Or when I had that C in there, it's caused an exception, and then that exception seems to stay in the memory, whether you program it again or not. And the actual problem is, and it can take you hours to solve if you've done 100 more lines after this. So that was the initial problem. I put C in there after C, which is a longer string compared to the text. Text is 3 characters. C, as we've seen here, is 11, excluding a null character. And in an earlier try with this debugger, it gave me a list over here, result. So I went to the result, which is here. I changed this result. It was something like 8 or more. And as we've seen in the examples and conversions, that should be a 7. So all the time I was running longer strings, 7 was plenty. When I started running like a byte, I dropped it down to 3. But then later on, put a C in here, didn't have any trouble, not till I turned it off and came back the next morning. And what did I do last night? Well, I did 100 different things last night. So really the message for this video is, if you're not sure, have a look at the help files and make sure your character array and your conversions have enough bytes allocated to them, or you will be in trouble and you'll have a bad day, as I did. The bad day was further compounded by the fact that I'm not familiar with this debugger, but looking at the list, it does point you in the right direction. So you don't necessarily need to know all these assembler language parts. Just clicking on this puts you in the right ballpark. Well, I stop that. Yeah, that debugger's not running. So hopefully this video's helped. Thank you very much.